Okay. Oh yes, and can I pan out the pad? Sure. If you want, what I can do is I can make the notes for the day. Yeah. The video will have voice and everything. It won't just be. It'll be just like what you hear and see. So you'll see the my screen here with the lecture, and then you'll hear my voice. I've already posted 2 lectures up. If you had seen those, it's going to be just like that. But what I can do is I can put up all the lecture notes for the semester up, and then I'm going to put all the completed notes up. So I'll make one, under the modules, I'll make one called Notes for Class, and then the other one will be Completed Notes for Class, so that you guys can have both of those. It should be up. I think I put it in the announcements for last week, but this week I put up a module for. This week I put a module up for week 9. I think I did week 8 for you guys last week too, didn't I? Or 2 weeks ago. I can look and see, but I thought I had done it. I know your videos are up. But okay, let's get started for today, so we can talk about this and try to pick up on this information. So the first thing, so they're in the modules. They were under week 8, then I assume. So the definition for today that we're going to be using a lot is the definition for the antiderivative. And what the antiderivative is it's a function, is called the antiderivative of another function on some interval if the derivative of the capital F function equals our lowercase function for all of the x's in our interval I. So that probably doesn't mean a whole lot to you guys, so you're probably a little bit confused, and that's okay. I'll explain that to you guys. So in essence, what this is saying is if I have some function, some capital F function, and take its derivative, it's going to be equal to the derivative of some other function. The theorem that we have right below there is going to be a better example of it, where we add the constant. So let me show you a function. So if I had, if I told you that our function was like x squared, right? We know that the derivative of x squared is 2x, right? So the derivative of that is going to be 2x. Does that make sense? We remember that. But that was going from given a function and then taking its derivative to get some new function. But what we're doing here with the antiderivative, instead of going this way, we're now going to be going this way. And so when we go back the other way, I need to find something that's going to be equal to 2x when I take its derivative. So the thing that I can take the derivative of and get 2x is going to be something that is x squared. But the important piece is we also have to remember that there has to be the addition of some constant, because when we take the derivative of x squared plus a constant, doesn't that still give us 2x? Does that make sense to you guys? Sure. So watch this. So let me look at this. So if I had, and I'll do it as a picture so you guys can see it. Ooh, dang it. All right. So if I have this function here is f of x is equal to x squared, correct? So when I take the derivative of that, what's the derivative of that function? Isn't that 2x? Okay, but if I took a function and it was up here, and I said, all right, this one here is going to be f of x is equal to x squared plus 7, what's the derivative of that? Isn't that also 2x? Yeah, so since they're both 2x, if I'm going to go from I don't know what my function is, but I do know that the derivative of it is equal to 2x, when I go back to my function, I'm going to get x squared, but I don't know which one it is, so I have to add that plus c constant. Does that make sense? And feel free to use your mic if you need to talk to me. That's totally fine.
So are we looking for the constant?
So we will eventually look for the constant, but what we're doing here first is we're doing the general case. So all things that have a derivative that's equal to 2x are going to be equal to the antiderivative x squared plus some constant. I don't know what that constant is because I don't know where I'm going to fall on it, but I know that there's going to be some constant to it. That constant could be 0, it could be 7, it could be -3. Does that make sense?
Yes.
Okay, cool. Let me erase that. But that's the gist of it. And so that's why we always need to add that additional constant. So let me do some examples so you guys can kind of see. And I have 3 that I want to show you. So the first one is going to be for sine of x. And so if I have f of x is equal to sine of x, we're thinking about this now backwards. What gives us a derivative equal to sine of x? What do you guys think?
Cosine?
That's right. So we're going to get our antiderivative is going to be equal to negative cosine of x, right? Because the derivative of cosine gives us negative sine, but we need the negative. But one important piece that we need to remember is we have to add the constant to it, because we don't know if negative cosine of x had a +1 or a +2 or a +100, because when we take the derivative of the constant, we're going to get 0. Does that make sense to you guys?
So for this section, all we're gonna do, we're just flipping it and then plus c.
Correct.
The constant, and we're not gonna be as of now. We're not looking for that number.
No. And now we will do an example in a bit, but right now all we're looking for is when we do the general case, when you're not given what's called initial conditions, you're only going to be looking for the antiderivative and then adding a constant, because the derivative of a constant is always 0.
And the capital F is?
That's the antiderivative. So,
okay, for sure.
So if you look at it here, capital F is the antiderivative.
All right.
And this will lead us to what's called the integral in chapter 5. Okay. Here's B. So if I have a function and it's equal to 1 over x, what derivative, what function's derivative gives me 1 over x?
ln of x plus c.
There it is. So we know, and that was Max, right?
Yes, sir.
I know your voice. ln of x plus some constant c. When we take the derivative of that, and this is how you guys can always check these problems, which is so cool. We never have to guess to see if we're right. So if I take the derivative of this, I know that that's going to be 1 over x, and that's going to be plus 0. So that's going to give me exactly what the original function was, which is that 1 over x. Is that making sense to you guys overall?
Yes. Yeah.
Okay. And those of you who don't want to talk, feel free to, you can type in the chat. I can see it on my screen. So if you don't want to talk, it's okay for you to just type it in on the side. I just want to make sure that you guys are good. Okay, now this one here is a little bit trickier. This is part C, and part C tells me if I have f of x is equal to x to the n, and I know that n cannot equal a -1, what should I end up getting? So let me do an example just to try to help you guys, and then I'll do some more examples going forward. But like we know x squared, right? So if I have x squared and, sure, that's fine. I can go x squared. So what's going to happen here is, what is going to give me, what's the antiderivative that would give me x squared as an answer? So if this was my function, what would give me that as an answer? What do you guys think? From the derivative rules that we know, if we're going to end up with x squared, shouldn't it be x to the third? Because the derivative of that is going to give me the x squared, correct? But something important is I have to divide by 3. So this ends up being the antiderivative. And I'll prove it to you guys that this is the answer. Because what's the derivative of x cubed? Isn't the derivative of x cubed 3x squared over 3? And then the constant becomes 0. So what happens to the 3's? Don't they cancel out? And so I get x squared. So the antiderivative's derivative gives me the original function. Do you guys see that? So I'm going to give you a general rule to this so you guys can have it. And then we'll do some examples together because I want to spend some time really making sure that you guys get this, as it's an important practice for you to get. May I erase this little example that I have?
Yeah, that's fine.
Yeah, that's fine.
Okay. So what we noticed in this problem, if you paid attention to it, what we ended up getting when we had the antiderivative, didn't we have x, the power added 1, right? Because I went from x squared to x to the third, but then didn't I divide by that new power? So then I divide by that new power, and I have to add a constant. I should write these. I should box these so you guys know. That's one answer. That's another. And then this one is the other. So the integral, or the antiderivative in this case, of the power rule, you know how in the power rule, when we're taking derivatives, it took away 1 from the power and then put the power in front? The antiderivative adds a power and then puts that new power as the denominator. So let's do some examples because, well, I think you need the practice, and I think it's a good practice. So I'm going to scroll down a little bit and do some examples with you guys. So how about you guys try this? I'll make it a relatively simple one to start. So if I have f of x, lowercase f of x is equal to x to the 5th, what is the antiderivative going to be equal to?
X to the 6th over 6 plus c.
That's right. Does that make sense to everybody? Is there any questions on that?
I think it makes sense.
Okay, so let me throw in a twist, right? Because throwing a twist in is always fun. So how about I gave you f of x is equal to x to the 3rd plus 4. Now, we're looking for the antiderivative.
It's x to the 4th over 4 minus 4c.
X to the 4th over 4. That's right. But it should be plus 4x plus c. Because look, when I take the derivative of the x to the 4th, I'm going to get 4x to the 3rd. So the 4's are going to cancel. the derivative of 4x is going to give me the 4, and then the derivative of c is going to give me a 0. Does that make sense to everybody? So we can look at it. I'm going to get 4x to the third over 4 plus 4 plus 0. And we can see that that gives us our original function back. So here's where the introduction of the antiderivative, it is going backwards, right? It is the inverse of the derivative. So the weird thing for you guys is all the derivatives that you've learned, you're now going to be going backwards on them, and you have to be able to backwards think. So this is going to take some effort and some time to study, as you guys can tell. All right, let me give you another one and see if you guys can do it. Why don't you guys write your answers on the chat, and I'll do the answer after you guys have posted up your answers. And then after that, I want to do one more weird one, and then we'll go on to an example problem, a different type of example problem. Okay, a couple people got it. All right. It's looking like you guys have it. So we can see from the example, my antiderivative is going to be x add a power, divide by that power, right? 5x plus c. Awesome. Now, let me throw in a little bit more advanced one and see if you guys can get it, and then I'll move on to a different example. So, okay, what if I gave you 3x to the fourth plus 2x plus 3? You guys go ahead and try this one, and then I'll do it for you guys so you guys can make the connection. I wanted to throw a coefficient in front to see what that does to you. Carol, what do you mean by so always add one number? Oh, to the power? Yes. That is the power rule for antiderivatives. No problem. No problem at all. Okay, so let me go ahead and show you guys this just so you guys can see. So the antiderivative to this one is simply going to be the 3 stays there. This becomes x to the fourth over 5 plus 2 stays there, x to the second over 2 plus 3, but now that gets an x, right? And now we have to add our constant. Now we can clean that up, so we will. And we'll get 3/5 x to the fifth plus x squared plus 3x plus some constant c. Does that make sense to you guys? All right. So that's just the gist of the antiderivative. Now let me use it in a word problem for you guys, because I think that will be so much more fun. Okay? Any questions on it, just to make sure before I move up?
I do have one question.
Sure.
So why does it still remain 3/5 for the x1 and x5?
Why is it 3/5 in the front?
Yeah.
Well, the 3 is going to stay there. The 5 that came to the denominator is just basically like multiplying by 1/5, right? So what's 3 times 1/5? Isn't that 3/5?
Yeah.
So that number there doesn't cancel. Now in the second term where I had 2x squared over 2, the coefficients cancel each other. And so I end up with just the x squared piece. Does that make sense?
Yeah, thank you.
Okay, no problem. Okay, so let's go up and do this this little particle movement problem. And there's some cool stuff that's being told to us here. It's telling us that the particle is moving in a straight line, and it gives us a formula. It gives us the formula for the acceleration, and then it gives us 2 bits of information. It tells us that the velocity is a negative 6 centimeters per second when the time is 0. And it tells me that the position of this thing is at 9 centimeters when we start again at time 0. They want us to find the position function. So they want us to find the s of t. Well, if we go back to the things that we've done in this class already, don't we know some things about this? So when we started this class on day 1, I told you that s of t was the position function, correct? And I told you that the derivative of s of t was my v of t, right? And the second derivative of the position function was the first derivative of the velocity, which would give me the acceleration. Do you guys recall that?
Yes.
Okay, so in our problem, we're starting off with a of t is equal to 6t plus 4. Well, we want to get to velocity, and then from velocity we want to get to position. So if I'm going to go from acceleration to velocity, am I not taking the antiderivative of acceleration? Right? I'm going to be...
You are.
Yeah, I'm going to be taking the antiderivative to it. So then my v of t is going to be 6t squared over 2 plus 4t plus some constant c. Does that make sense? So then my v of t is going to be 3t squared plus 4t plus c. Now, when we get to this point, they've told me something about velocity. In the problem, they told me that velocity, when time is 0, we're going to have a negative 6 centimeters per second. So I'm going to use that information here to find out what my constant is. So I'm going to go, all right, v of 0 is going to be 3 times 0 squared plus 4 times 0 plus some constant, and that should be equal to negative 6. So that tells me that my c is a negative 6. So, without any doubt, I know that the velocity function for this would be 3t squared plus 4t minus 6. Do you guys follow how I did that?
Yes.
Okay. This v naught, or v of 0, is called an initial condition. So it's important that you guys get that this, along with this guy, are both initial conditions that help us to be able to find our constant, our unknown constant. Okay? Now from here, we're not done. We need to find the position function, and the position function is the antiderivative of the velocity. So then I'm going to have s of t is equal to 3t to the third over 3 plus 4t squared over 2 minus 6t plus some constant c. Now, Now, s of t then is going to be t cubed plus 2t squared minus 6t plus some constant c. But we have our other initial condition that tells us that the position when time is 0 is 9 centimeters. Do you guys follow that?
Yes.
Okay, so then we're going to go S of 0 is going to be 0 to the third plus 2 times 0 to the second minus 6 times 0 plus C, and that should equal 9. So here we know then that C is equal to 9, and so S of t is equal to t cubed plus 2t squared minus 6t plus 9. And this is the position function for our problem. Do you guys have any questions on this at all?
Yeah, I got a quick question.
Yeah.
So I understand all the steps that you, like, I just want to make sure that first B of t and the second B of t, you just found the antiderivatives for that, correct?
So the first v of t, all I did is I demonstrated the steps, right? So I went t squared and then divided by 2, and then I put in the t and I added the constant. In the next v, so here I'll number them just so you can see what I'm talking about. This is the first v and the second, and then there's the third one I was plugging in, and here's the fourth. In the second one, all I did was clean it up, right? So 6 divided by 2 is 3, and I cleaned it up. In the third one, I used the initial condition to find my C, and then the fourth one is what the actual equation is for this position function. Does that make sense?
Yeah, but why did we divide by the 2? Just because the power is 2?
Yeah, so it goes back to this rule that I gave you right here. So whenever you have the powers, you're going to add 1 to the power and then divide by that. Whatever the new power is, that's what you divide by. And then you add C.
All right.
Okay? Oh, right here. Are there any other questions on it? No? Okay. So then from here, what I'm going to do is I'm going to, I'll stop the recording,